This is a walkthrough of Quiz 2 from Physics 131, Fall Semester 2021. An arrow is launched horizontally from a height of 20 meters on level ground. It lands 140 meters away. What is the initial speed of the arrow? Start with the diagram. Shot horizontally from a height of 20 meters, lands 140 meters away. It's 140 meters in the horizontal direction. Let's put the initial speed on there. Shot horizontally, gravity pulls it down, lands 140 meters away. The distance traveled by the arrow in the vertical direction is 20 meters downward. We do projectile motion problems one direction at a time. The initial speed of the arrow in the vertical direction is 0. It's shot horizontally. It has no vertical speed. So we can now get the time of flight of the arrow from the vertical direction. Y, 1/2 a sub y, t squared plus v initial y, t. V initial y is 0. Acceleration is minus 10 meters per second each second. Distance 20 meters down. Now we got to solve for t. 1/2 times minus 10 is minus 5. Divide both sides by minus 5 meters per second squared. Take the square root. We get 2 seconds. Let's check that. You drop something. How fast is it going after 2 seconds? It's going 20 meters per second downward. The average speed is 10 meters per second because it started at 0. If it averages 10 meters per second for 2 seconds, it goes 20 meters. Check. And now let's move to the x direction. It goes 140 meters in 2 seconds. Its average horizontal speed must be 70 meters per second, but the horizontal speed never changes. That's the initial horizontal speed, that's the final horizontal speed, that's the average horizontal speed. Gravity does not act in the horizontal direction. The horizontal speed's constant, so the initial speed of the arrow must be 70 meters per second because it's all horizontal in the beginning. That's the answer to problem 1. Problem 2. An arrow was shot at a speed of 26.0 meters per second at an angle of 22.62 degrees above the horizontal. Assume it is shot at ground level and ignore air drag. What's the maximum height, where it lands, and what's the speed 1.5 seconds after it is shot? Let's start with the diagram. Shot at a low angle. Let's add the initial velocity. It's important to understand that this 26 meters per second doesn't belong in any equation. We don't know what happens to this 26. We know what happens to the x component, and we know what happens to the y component. We can't do any physics on that 26 meters per second. We have to get the horizontal and vertical components. V sub x is 26 meters per second cosine 22.62, that's 24 meters per second. V sub y, 26.0 meters per second sine 22.62, sine is opposite right there. That's 10 meters per second. Now we're ready to go. We know what happens to those speeds. The speed in the y direction drops by 10 meters per second every second, and the speed in the x direction does not change. So let's replace this vector at 22.6 degrees with the components. There we go. 10 up, 24 over. In the horizontal direction, the arrow is going to travel 24 meters every second it's in the air. The way we get how long it's in the air is from the y direction. In the vertical direction, the speed of the arrow gets reduced by 10 meters per second each second. The arrow will reach the peak in 1 second. It takes gravity 1 second to scrub off 10 meters per second. So the arrow is going to be at the peak in 1 second. The average speed over this 1 second, it starts at 10 and ends at 0. The average speed is 5 meters per second. If you average 5 meters per second for 1 second, you go 5 meters. That's part A. It's 5 meters high, maximum height. The arrow is going to have a time of flight of 2 seconds. 1 second up, 1 second down. In 2 seconds, it's going to go 48 meters, 28 meters every second. That's part B. Now part C, how fast is it going at 1.5 seconds? That's going to be about here. The horizontal component of the speed is at 1.5 seconds is 24 meters per second because it's 24 meters per second all the time. Let's put that on the diagram. Now we have to get the y component. Gravity takes away 10 meters per second every second. If it starts at plus 10, And x for 1.5 seconds is going to take away 15 meters per second, so it's going down at 5 meters per second. 10 minus 15 is minus 5. So let's put that in the diagram. Now we have to get the speed, and we get the speed with the Pythagorean theorem. We want the hypotenuse. 24 and 5, we want the hypotenuse, so we use the Pythagorean theorem. V sub x squared plus v sub y squared square root, and the answer is 24.5 meters per second. That is quiz 2.